shall proceed
Ang mga
while
nakakawalang-
waiting for the others. Okay, so welcome to the technical seminar, the webinar. Actually, it's a meeting. The role of BIM in sustainability, energy, and environment. So, good day to all of us because I don't know if we are in a morning session or in afternoon session in the particular place where we are in. Before we proceed, I would like to request our PP for all season, Engineer Nap Cipriaso, is our past president for year 2010.
2012.
2012. Okay, sir, take it away.
Masyado mong pinatatanda. Dalawang taon na yung
Introduction of
pinaba.
our
Good evening.
Our
fellow
technical presenter.
engineers. Good morning dyan sa Toronto kay Engineer Ace. At midnight yata sa mga kasamahan natin na nasa Pilipinas. Again, welcome po kayo dito sa ating unang webinar. At akin pong ipapakilala ang ating speaker. Ang ating pong speaker and presenter is used to be here in Jeddah. Nagtrabaho siya sa ilang consulting companies here like HAL Consultants and Saudi DR. And he has been a BOD at that time that I was the president in 2012, and prior to that, during that time, I think Engineer Engineer Rainier, if I'm not mistaken. Then Ace has transferred to Hong Kong, at kung saan siya maraming magandang experience doon na na-share sa akin, lahat ng experience I mean. And then he transferred to Singapore. From Singapore, he migrated to Canada. And now let me read some of the highlights in his career. Ace Glenn Garcia is an EIT, LEED AP, and WWEL AP. He is a mechanical designer and energy modeling lead at Matt Forsyth Engineers in Toronto, Canada. He is a dedicated and passionate environmental professional, and he focused his decade-long career in building service engineering designs and sustainable design technology solutions. He has a wide gamut of project accomplishments from residential mansions, industrial and institutional facilities, high-rise commercial buildings, and mission-critical projects across the Middle East, Southeast Asia, North America, UK, and Australia. He is a member of the Professional Engineers Ontario, PEO. He is a member of Chartered Institution of Building Service Engineers, CIBSE, where he is one of the contributing authors of Building and Extreme Environment Tropical publication. A member of Chartered Association of Building Engineers, CABI, in UK. A member of the American Society of Heating, Refrigeration, and Air Conditioning Engineers, ASHRAE, and Air Subcommittee Chairman for Institution of Engineers in Singapore in year 2016 and 2017. Of course, he was then a PSME WRSA BOD from 2009 to 2012. Without further ado, let us welcome Engineer Ace Glenn Garcia from Toronto.
Thank you so much, Sir Nap, for the introduction. Yes, I'm I'm really proud to be one of the BODs in PSME WRSA, and PSME WRSA is it's like a family to me when I was in Middle East, and we really support and help each other when it comes not only in career but also in personal life. Thank you. So I'm really glad that they had invited me to present regarding the role of BIM in sustainability in energy and environment. So going here in the presentation, like I always do, so I usually explain what is my background. So this one is an iceberg taken by Camille Seaman. She's a environmental photographer. So this one encapsulates the effects of climate change. Like you can see, like some of the wildlife animals are coping up with climate change and the melting of glaciers in Antarctica. So we'll cover that in the effects or the role of BIM in sustainability, energy, and environment. So the agenda for today will be four topics. The first one would be the BIM integration. What would be our tools for BIM, and architects, engineers, and energy analysis, or what are the platforms or software that we'll be using, and sustainability. The second topic would be the LEED certification. I won't be tackling the LEED certification in detail, but it would give you a bird's eye view of what are we going to do for LEED when it comes to energy modeling processes. So also what will be the type of energy conservation measures that we'll be doing, and of course the modeling advantages and limitations in doing energy modeling. And the third topic would be environment and climate change. And the final one is how do we adapt or mitigate and making sure all our building could withstand climate change and become resilient. Let me know, Sir Aldrin, if you want the conversation to be like while I'm discussing, you can ask questions, or you can ask questions after the presentation. I'm free. I'm okay with both.
At your convenience, Engineer Rice.
Okay, sure.
Which will be better.
You can ask. You can ask during my presentation, or you can always wait at the end of the presentation so we can have a very interactive conversation or question and answer portion. Yeah, thank you, sir.
Okay, so I suggest that
So
those who
moving
will
on.
ask questions, they will raise their hands so we can unmute them.
Okay, perfect. Thank you, Sir Aldrin.
Okay.
So like Sir Nap said, this is my profile. I won't go into this. So you already know that I'm currently in Canada as an energy modeling lead. And then of course a BOD officer from of the PSME WRSA. So what is BIM integration? You can see it's very typical for like building information modeling, where we have a program, we have conceptual design analysis up to the operations and maintenance of the building. But for some of the energy modeling processes that we have done, we usually go to the conceptual to detailed until the operations and maintenance. So some of the process, like during construction, we're not able to do any modeling because we usually do the the modeling during conceptual and operational phase. So again, this map clearly specifies where building information modeling is very active, like especially in countries in Singapore. In 2015, when I was there, the government asked that it's mandatory for all their building submission to be in Revit or somewhat similar to Revit. And even here in Canada, we typically use Revit or 3D software to submit our drawings. So a lot of countries are already doing BIM, and even in the Philippines, they're starting to become very popular, and some companies make their drawing production mainly in the Philippines. So what are the tools that we usually use as a designer and energy modeler for BIM? So there's a lot of things like Revit, Autodesk, like even AutoCAD, IES, eQuest is and Energy Plus. So these are the energy modeling softwares that we use. SketchUp, Design Builder, and Climate Consultant. So for us, these are the tools that we use for us to determine what are the energy analysis, benchmark, climate analysis, what will be the massing and orientation, types of envelope, natural ventilation that would go in and out of the building, different kind of like daylight harvesting study, or artificial light, what would be the possible lux level inside the building, and of course, finally doing the energy modeling. Moving on, so let's say we have the Revit or AutoCAD drawings. So how do we actually convert? So there's are some of the processes we convert the BIM or building information modeling software or drawings to the energy model. So some we can use IFC file from Revit, and then these are the conversion software or utilities to use for us to convert to the energy model. So very popular for us is doing either DWG or GBXML or DXF in some cases, like Energy Plus and eQuest use this file to convert and create our energy model, and in IES we either use GBXML or DWG. So here are an example of converting Revit to IES. So there's a lot of plugins where you can click the button to convert the Revit file to ISVE, which makes the geometry and all the building or building to wall ratio as accurate as possible. So you can see that here it's almost like identical to the Revit model. The ISVE model is almost identical to the Revit model. So if we start on the word simulation, I always say building simulation or building performance simulation. What is simulation? So from the Latin word simulare, it's called to pretend. Or so basically what I usually do is just pretend. So my work is just a big pretension, or I'm a big pretender in most cases. So building simulation is a mathematical model where we predict what will be the possible output based on the given inputs from either weather file or architectural model or mechanical information. So we can model different types of model depending on what's the criteria or what's the objective. And we can model depending on what could be the desired output based on the certain system that we want to simulate. So here are some of the types of like a typical modeling process that we use. We can even further improve or simplify this process. So it starts like having a Revit model or architectural model, and then once we have different kind of thermal zones, like mechanical engineers usually design their system as per like thermal zones or blocks. And then once we able to know that system, mechanical and architectural system, we will run the model based on weather file and which energy tariff, or if you have energy bills on that certain section. So each country and each zone or each municipality has its own energy rates. So we taking that to account, and then we run the model and test it whether it passes or not. If not, then we'll have to go back to the entire process to calibrate. And if it passes, then that's the end of the process, or we will submit the energy model. So this one is one of my favorite graphs. So it indicates not only the process that we've done in energy modeling, but also in design. So here you can see that to be able to have a lot of savings in your project or in your design, you would have to start during the pre-design until the schematic design. And if you go beyond the design development or beyond the schematic design, you will have to need a lot of effort just to get a minimal savings. So let's say you missed some of the opportunities during the design and you implement it during the construction phase. So where you already installed the fan cool unit, you installed the chiller, and then you realize that you can't meet the energy savings that you want to meet. So you would have to either redesign the system, and there's probably a lot of like limitations where architects would say, hey, you can't do that because of the space, or the ceiling void is too tight, or the owner would say that we can't do that because there's a budget financial barrier or limitations that we can give. So that you will have to to give a lot of effort just to get minimal savings. So I would definitely suggest to start your energy modeling process or design process during these phases. So what are the purposes of BIM? So there's three types of purposes in BIM. So the first one is comparison. So how do you compare each individual system based on energy efficiency measures? The second one is compliance. So it's either compliance with the green rating system like BIM or Burden Philippines, or LEED, here compliance with permit. So we do a lot of those energy modeling for compliance. And lastly is prediction. So prediction is, let's say you want to know what's your current system, and if you implement this kind of, let's say, energy conservation measures in your plant, or peak shaving, what will be the predicted output of that system. So it's very useful from the from your design up to the operations and maintenance of the building. So we do a lot of energy modeling from different kind of requirements from the client. So we have energy conservation measures. Let's say these are the facade or the passive analysis. So we test different kind of facade, whether we'll have to improve the facade. Let's say R value from R15 to R20, what would be the impact of that facade? Or if we have, previously we have single glazed windows, now we have double, triple glaze. So we can test that and see what's the effect of that system or that glazing to the energy. So same with here, we also have, so we have three energy conservation, typical three energy conservation measures. One is passive or facade. The second one is behavioral, and the third one is mechanical system. So for behavioral system, it's usually like occupancy sensor or smart thermostat, or time-based schedule operation. So we'll see that in the energy model. And what's the mechanical system like? If we improve our chillers or boilers, or we have energy recovery ventilators, what will be the effect in our energy So the energy conservation measures look up for each singular system in the building, or it can also be a holistic or a combination of each of the system from facade, like combining R value of 20 and having a good smart thermostat and energy recovery. What will be the effect on our building? So like, for example, here, there's an existing building where they had given us like the monthly bill for the building for both gas and electric. So we usually calibrate the energy model based from these bills and based from the data taken from the building owner. Well, they would say, okay, we usually operate our building based from this time and this time, and we have this much lighting power density or receptacle loads, and we have this much mechanical information or building facade. So we will try to run our energy model as accurately as possible to match these bills, just to make sure that we can create our baseline. So like I said, if we would need to predict the certain effects of a new system that you want to implement in your building, we'll have to make sure that the current operations is modeled accurately, so that once you implement a new system, you can see the effects or the reduction of energy on your building. So LEED certification. So doing energy modeling, if you're familiar with energy in the atmosphere, it does have a lot of points for LEED, especially if you can give the building a lot of energy saving or energy cost savings. So we do model that in energy model and show or demonstrate that the building can actually save energy and money based from the current codes. So like I said, depending on the LEED certification or LEED process that you want to pursue, and what's the energy cost savings that you can save, these are the points that you can achieve. So before, when we started the energy modeling and also design, we only have climate zone 1, and Philippines used to be climate zone 1. In some parts of some countries used to be climate zone 1 until climate zone 7, and now we have additional, because of climate change and the weather is becoming hot, they actually decided to have additional climate zone, which is climate zone 0, which is very hot, extremely hot. So like all certifications, from even permits or LEED certification, you have to make sure that the proposed model is more efficient than the reference model. So if you see in this graph or this image, you can see that the reference model is heavier than the proposed model. So in an energy model, what will be the let's say you have two models, one is proposed and the other one is reference model or the baseline. So what will be the same for both of these models? So first, they should be the same area and geometry. Otherwise, the comparison for this would be like comparing orange to apples. It should be apple to apple comparison. So they should have the same weather file, same orientation for baseline 0. Schedules, they should have the same operational schedule, infiltration rates, not unless that, though this one can be justified, you can explain to the LEED certification or even the municipal officer here that based from our improved building envelope, our infiltration rate has also been improved, because if you have a poorly installed building envelope, or you have a very thin walls, then you have a lot of infiltration loads as compared to having like, let's say, passive house design or having a better envelope information. Then the infiltration can be different from the reference model. But for the typical use for lead certification, we usually use the same infiltration load. We also have same receptacle and equipment power density for both reference and proposed model. So what would be the differences of the proposed and reference model for lead? So envelope performance, like I said in my previous discussion, or I mentioned that they have the proposed and reference model would have different R value of wall or even window to wall ratio. They might have, proposed model might have higher or smaller window to wall ratio depending on the project, and the reference model will typically have 40% or less depending on the proposed model. So let's say if the proposed model only have 10% window to wall ratio, so meaning you have small glazing in the building, then to be fair, that would be the same for the reference model. The reference model would also have 10% window to wall ratio. But if your proposed model is higher than 40%, then the reference model would just stay at 40. So lighting power density, you would have different lighting power density where this one might be using ASHRAE lighting power density recommendation. And for the proposed model, it might use like LED or much high efficiency lighting. So the loads will be reduced. And same for the outside airflow. So let's say this model is using just constant like ASHRAE 62.1 recommendation, where you also comply with ASHRAE 62.1, but you also have, let's say, demand control ventilation or any kind of passive system that can reduce the loads, or even like ventilation efficiency. So you might have a different ventilation efficiency depending on the system that you have proposed in the energy model. So let's say you have done the energy and atmosphere, you have submitted the model. So for lead, based on that, once the GBCI approved your submission, you can earn different kind of points from lead certified up to platinum. So what are the modeling limitations that I usually encounter? So let's say user interface. There's a lot of energy modeling software that are really hard to understand, and it's not user friendly. So you would have to do a lot of training just to understand what is happening inside your model. Lack of BIM integration. So let's say you have a Revit model and you want to convert that in a eQuest energy model. So there's a gap there that it's hard to just click a button and then you have an eQuest model. So you would have to do a lot of workarounds just to get the Revit model to the eQuest model. Graphics and complexity of geometry. If you have an eQuest model or like Energy Plus software for energy modeling, there's a limitation on geometry where you can't model dome or round structures. You can't model like complex shading structure. So not all energy modeling software are created equal. So like system types in complex mechanical or electrical systems, let's say if they have a modified or a customized HVAC system, some energy modeling software could not do that or could not simulate that, where some like IES can able to do a lot of complicated mechanical systems and even like control methodology. So in sustainability, like for LEED, you have to balance like the triple bottom line where you make sure people, profit, and planet benefits. But for energy modeling, you have to make sure these three are balanced. So you have a good energy consumption compared to the baseline. Your energy cost is lower than the baseline or the reference case or instance is better than ASHRAE. And also you have to make sure that your greenhouse gas emission is lower than the proposed model. So there's some instances like if we run like greenhouse gas or let's say comparing natural hydronic boilers to ground source heat pump, you can see that the hydronic boilers would have slightly higher energy because the maximum for condensing boilers will be around, let's say, 95% efficiency, but the heat pumps can go to around COP of 4 or coefficient of performance of 4 or 3. So that's a lot of efficiency. So you'll see that boilers, natural gas boilers will be high in energy and also greenhouse gas emission. Oh, well, this one would depend on the location that you have. There's some parts of the world where we have the greenhouse gas emission for natural gas is less than electricity. Here in Ontario, our electricity is very, very good, where we have very, very low greenhouse gas emission, but we have bad greenhouse gas emission for each of the cubic meter of gas. And of course, the cost here, the cost of greenhouse gas is cheaper than electricity. So you would have to, on your energy model, you would have to make sure that all of these are in line every time you do your energy modeling, and at the same time, your mechanical system or your design. So moving on the environment. So we design our BIM or our building information modeling based from a lot of projects. Can be residential, industrial, or transportation, or even commercial. So we have like hotels, we'd have like commercial buildings. So those buildings that we create in our drawing are being constructed. And like here in the Philippines, like 11% will be commercial and 30% will be residential. So if you combine those, it's like almost like 40. Yeah, it's 40%. Or 40%. So that's a lot of energy in the Philippines that we would have to, if we reduce the energy for those projects, then that will be better in our environment. So always think that once you do drawings in Revit or AutoCAD, remember that this is not just drawings. These drawings would be converted to the actual project and therefore either emit a lot of greenhouse gas and also consume a lot of energy. So just bear that in mind. So you can see that these are the energy plan in the Philippines, where what will be the use of each individual energy sources. So you can see that majority of the energy source in the Philippines will be oil and coal, and there will be a small amount of percentage for wind, biomass, and solar PV in the Philippines. So that contributes to the amount of, let's say, if you use certain kilowatt of energy, what will be the conversion in greenhouse gas emissions. So you can see that it would increase. So the more energy you have, the more greenhouse gas emission that you will emit in the plants in the Philippines. So you can see that the CO2 emission, this is taken from the World Bank. I think this one is 2008. So as you can see, the projection of the Philippines CO2 from 1960 onwards is skyrocketing up. So, and based on the on the actual projection that they have to 2040, this CO2 emission would go up. So what would be the effect of having so much CO2 in the environment or in the Philippines? So we'll have climate change. So climate, like we all know, climate has changed. You definitely see a lot of flood and heat in the Philippines and same in Saudi Arabia. So there's a lot. Climate are already changing or already has changed. So these are the graphs of each individual agency from Japan to US. So they are agreeing on some of the temperature changes in the Earth. But regardless of what they are disagreeing to, you can see that the temperature anomaly globally is rising up. So here. So what will be in the Philippines? So you can see when it comes to climate change vulnerability, this study says the Philippines they have identified 16 countries across the 170 countries across the world. So out of those 16 countries, the Philippines is number 6 among the most vulnerable in climate change. So not only that we are very near to the equator, but also we are covered by seas. So there will be like massive storms. Well, you can see that storms before when we're children. It's not much. Then every year it's like a big tornado coming in our country. So like I said, climate has changed, but it's also still changing. So you can see that this one is taken from DOST, that the black line is the historical trend of temperature, and the green, blue, and red are based on assumptions from low, medium to high assumption of emission and what will be the temperature increase in the Philippines. So we are in the 2020. You can see that the increase of temperature in the Philippines will be, well, we probably already experiencing it. So you can see that Manila is becoming really hot, and probably like if you're in the place of Davao or places in Mindanao, you can see that during the summer months it's becoming really hot. So you can see that here the sky blue one, like additional one degree of temperature increase in the southern part of the Philippines. So if we fast forward from 2020 to let's say 2040 or 2050, what will be the increase of temperature? So you can see 2020, 2050, so that is just 30 years from now. And if you think 30 years from now is long, to me, it's like, when is year 2000 when you are just thinking about Y2K? Now it's just 2020. And it's 20 years is just really fast. And now it's just, if you go to 30 years from now, you can see that some of the average temperature, let's say if the average temperature in the Philippines now is let's say 35 degrees Celsius, you can see that you can have more than that, like almost 40 degrees. So you have to make sure that your building or the buildings that you're designing would be equipped 30 years from now to adapt to the climate change or to the increase of temperature. So this one I have morphed the weather file from IWAC. So I run different simulations and morph the weather weather data. So this one will be the weather from 2020. So you can see that there's still some 21 to 27 degrees during the morning and slightly in the evening. And as we go towards 2050 and 2080, you can see that Manila would almost be almost hot every time. So as compared before, we have cold season or cold air during the morning and evening. Now it's almost hot every time. It's like 27 to 38 degrees Celsius every time. So, like I said, you have to be prepared for that changes or climate change in the Philippines. So, what will be the effect of climate change or temperature rise in the Philippines? You can probably see fire, and because we would need a lot of AC, and AC needs a lot of electricity, and with our aging electricity network, either Meralco, they're not building a lot of generators or turbines to generate electricity, and therefore, with the increase of demand, we'll have a lot of blackout. So that would further increase our problem with climate change. We don't, our environment is hot outside, and we don't have AC, and it will increase to it will go to the health issues like having stroke and other health issues. And agriculturally, farmers would complain that they could not able to plant because of drought. So there's a lot of problems that you would have to consider just to make sure that we are ready in climate change. So I'll give you one more one video. I really like this video because this highlights the effect of climate change and like the demand of air conditioning and also the effects of that demand. So I'll just open it. So on that video, you can see that the cycle is going around. So hot climate. We will have hot climate and will require conditioning. Air conditioning would emit a lot of energy, bringing the temperature outside to be more warmer, more hotter, and then the cycle continues. So, like I said, we have to prepare our buildings for climate change. Same with not only the hot climate, but also the elevating uh, seawater. So here, this is the measurement for in Manila. So you can see that the sea level change is rising. So therefore, you can see that some of the areas here in Metro Manila are very vulnerable to the sea rise. You can definitely see that compared before. Um, we can see that during the 1990s that Manila seawater is really low, and therefore we don't have to worry about floods. But like in year 2000 onwards, you can see that even in the news, it's very common nowadays. So, so like I said, because of floods, we will have to say it's more fun in the Philippines, where foreigners will be enjoying the flood and having their scuba diving and some rubber boats probably. So moving on in Saudi Arabia, um, people in US, well, if you can see Teen Vogue, what a good source, right? It's for teenagers. So they would say in 2100, you can see that they're expecting that the Houston, Texas will be the same temperature of Jeddah, Saudi Arabia in 2021. So, and that's in US, where we usually think that US is a cold climate. So in 2021, they are expecting to be like Jeddah. So how about Jeddah in 2021? So you can see that the temperature in Jeddah typically is around 36 degrees to, let's say, 38. Moving on, it will be like 40 degrees, like typical temperature. It might go up. So the highest recorded temperature before is around 55. Correct me if I'm wrong. The last time I went there is like 55 degrees. Like all workers would have to go inside or stop working. And now, once we go to 2050 or 2100, then the temperature outside will be very much unlivable or unworkable. And also droughts, considering droughts in Saudi Arabia, it will further escalate the drought from year 2100. So if you're in Jeddah and if you want to stay in Middle East, then you would have to make sure that all buildings or all buildings that you design or operate would be ready for climate change. Though when it comes to the Middle East, Saudi Arabia is not too bad compared to Oman. Oman had a very severe water scarcity, so we're still okay compared to other Middle Eastern countries. So, like I said, when I was in Jeddah in 2009, I actually experienced this flood in Jeddah. So, who would have thought that Saudi Arabia would have or Jeddah would have this massive flood, and it affected, actually killed a lot of people at that time. So, again, I'll give you a short clip from the World Economic Forum regarding the climate change in the Middle East. So this video actually show a lot of what will happen, what will commonly be happening in the Middle East. So there will be like shortages. We already have water shortages in the Middle East, but it will further escalate that problem, and we'll have a lot of asylum seekers that are being displaced because in the country, like what's in the video, Egypt had more than 2 million people went out just to seek water and even other opportunities because the countries are experiencing a lot of droughts and problems due to climate change. So some people would say, well, Ace, you're saying that all the regions in Saudi Arabia would change and would be warmer. When we are in Saudi, either in Tabuk or Taif, we actually experience like snow for the first time. So where's the climate change? So some scientists says the climate change will not cause like uniform warming throughout the world, but because climate is changing, it would cause a lot of disruption or patterns in the weather, so causing a lot of unusual cold or wet or dry weather in some regions. So this is like a snowstorm in Saudi Arabia in March 2012. So we know that climate change will happen, like it's already happening right now and will happen. It will be even more years from now on. So how do we make sure our buildings will be resilient enough to withstand climate change? So as per the Resilient Design or Resilient Design Institute, what is the meaning of resiliency? So it's the capacity to adapt the changing of conditions and to maintain and regain functionality and vitality in the face of stress or disturbance. So it's the capacity to bounce back after the disturbance in climate change or interruption. So here in US, this was done by my previous company, Atelier 10. So they have provided their technical information in Urban Pain, where people in New York are already planning to change their buildings to face the coming climate change. So they're designing different kind of ways to make sure all the buildings in New York will be resilient enough. And same for Toronto. So they have plans for 2030 where the buildings must be efficient and resilient enough. Especially we are facing here in Toronto, we're facing floods. So we'd have to make sure that all our mechanical and electrical design can withstand the flood and climate change or any temperature increase due to climate change. So like, for example, if you want to make sure your buildings will be resilient, let's say you have a condo building or apartment building in Philippines, and you just say, well, I wanted my building to just comply in ASHRAE. So you can see the ASHRAE, let's say climate zone 1, R11 resistance value for the walls. So if you want to just comply with that, and let's say because we constantly experience blackout or brownout in the Philippines, and if you are old, like a senior people in the condo building or apartment building, and you stay inside, you can see that in 3 days there's a lot of temperature rise, where before during air conditioning days there's electricity, you are very comfortable at 26, 24 degrees. But because there's no electricity and therefore your HVAC system is not working, then you experience a sudden rise. But if you design your building, let's say, based on my energy model, I can improve my building from R11 by just code compliance to, let's say, R20, then you can see that there's a big drop of temperature. You can see that there's a slight temperature decay in having a better design or better envelope in the Philippines, and not only in the Philippines, and even here. So you have to make sure that all your designing can withstand climate change, because like I said, like 2020 or 2050 is just 30 years from now, and buildings usually go to around 100 years or more. So you have to make sure that the buildings you have designed now can be ready for the future. So how do we make sure that our buildings are resilient enough in climate change? So here we usually said that there's two things: you have to mitigate and you have to adapt to survive what's coming in the future, to survive the climate change. So let's say, okay, I don't want to adapt. I just want to do the same thing as before. Well, if you don't want to adapt, here's the formula. So if you don't have to adapt, you have to make sure you mitigate, 100% mitigate all your buildings, all your transportation. You have to make sure you have 100% clean energy. You have a better transportation, better lighting, or you can adapt and mitigate at the same time, so that you don't have to burden a lot of projects or design a lot of buildings that could be energy efficient, like zero emission. And there's a lot of complications with that when it comes to budgetary. Let's say in Philippines, not all infrastructure have budgets, but if you can balance the mitigation and adaptation, then you can survive what's coming in the coming years. And that will be the end of my presentation. Thank you very much. Feel free to ask questions if you have any.
Okay, for those who have questions, please, you can click the raise hand icon so that you can be recognized. From Engineer John Ray. Okay. Engineer John Ray, please raise your question.
Good evening, fellow engineers. Good evening, Engineer Ace.
Good evening. Nagkakaroon ng feedback.
Ano feedback? Wait.
I'll check on the.
There. Yan pa.
Okay.
Okay na pa.
Okay.
Okay na.
Sir, since it is simulation, we really need na magkaroon ng skill sa Revit, AutoCAD, and SketchUp po.
That's a good question, sir. You usually don't have to learn all the software like Revit, AutoCAD, just to model. Some modelers doesn't know how to do Revit or AutoCAD drawing, but
Very hard to use the Revit.
yeah, all they have to do is just learn the energy modeling software, which is also hard depending on which software you want to use. But I would still suggest now you have to familiarize with those software, because eventually you would need that software to convert the drawings to your energy model. So I would very suggest to learn that as well if you want to pursue the energy modeling field or career.
Thank you, Engineer Ace.
Anyone else from our attendees who would like to raise a question? From Engineer Miller Narbas? Okay, Engineer Miller, through your question, yes.
Following to the question of Engineer John Ray, sir, na-curious lang ako. So, itong anong ito, energy modeling or analyzer ba yan na na software?
Yes, sir. Energy modeling.
Similar ba yan sa sir, yung CAI, yung computer aided engineering na nag-a-analyze yung dating previous na yung Cosmos? Yung if ever may drawing ako na 3D pagkatapos sa subject ko siya sa parang mga tensile or compression ng mga anong simulation, parang ganun bang concept niyan or iba?
Thank you, Engineer Miller. Same concept. So let's say yung software, you have a software na isa-subject mo yung building sa tensile stress or any kind of stress and make sure that your design can withstand that stress, right? And you have a factor of safety.
Oh, pero yung sinasabi mo na software is anong sinisimulate niya, yung similar ba siya doon, yung kunyari yung temperature or ano ba?
So similar yung understanding because you subject your model just to make sure let's say sa structural, you subject that building to make sure that your structure is safe once you construct, right? In energy modeling, let's say you want to test your system. Let's say you have fan cold unit and you have a demand control ventilation system that you want to test. What would be the effect in annual energy consumption? So let's say once you run just a typical fan cold unit will have this much energy consumption throughout the year, and then you run DOAS with demand control ventilation, you can see that there's 20% savings in energy. Let's say you can save 100,000 to 1,000,000 reals or pesos every year. So you can see that there's a big amount of savings if you test your individual system. Same for like architectural facade or shading. If you want to know what's the effect of improving R value ng building more, shading, what's the effect on cooling energy. So without having constructed the project, you already know, or you have that you have tested the system na it can save money or energy in your project. So that's the role of the energy modeling, not only just for complying to code, but also in actual operation and return of investment. That's a good question. Thank you, Engineer Miller.
Maraming salamat, sir.
Okay, Engineer Miller.
Yes, sir. Maraming salamat.
Okay. Next, we have Engineer Bliven.
Raise.
Engineer Bliven, please raise your question.
My question is building information modeling. Do we have an application for that to realize what is the intellectual or intelligence model-based process for this one to come up?
Sorry, sir, paki-ulit yung question.
Meron po ba tayong application or any application or to test any model or building to input some information?
Thank you, sir, then for the question. Yes, we do have. So I'll have a sample here. Let's say we have a building here, which is a building here in Toronto, and this is an office building. So it's taken from AutoCAD drawings. So they have provided the area, the volume, what's the window to wall ratio, and they want to know, let's say they want to know the effect of improving the building R value. So we have input the R value or yung building envelope na in-improve namin from R15 to R25. So once we run the energy model, we can say that, okay, based on the system na in-implement from your AutoCAD drawings, we have run it, and you can save 15% of your energy costs. So we can say that based on those improvements, magkakaroon ka ng 15% energy savings from your building, and this is actually operating. And let's say 15%, your building is let's say consuming $100,000 per year, or let's say $200,000 per year. So 15% of that, it's a lot of money. And I'll give you one sample in Singapore. So let's say Marina Bay Sands, they are consuming, they're actually having $90 million energy cost. So that's $90 million per year. And when we are doing energy modeling or energy auditing as well, we are targeting 40% of reduction of energy, and therefore energy costs. So 40% of 90 million per year, that's a lot of money. And you can do that doing energy modeling. It would be very hard for you to reduce energy by just having site investigation and Excel spreadsheet calculation, and it would go to misleading results and even inaccurate results compared to doing energy modeling. Kasi sa energy modeling, you can simulate it virtually kung ano yung actual geometry, actual operation, actual weather happening, or you can even assume or morph the weather data to go to 2050 or 2080 weather data and assume kung ano yung pwedeng mangyari in the future to your building. So yes, there's a lot of application for BIM and also energy modeling in the actual world, actual project.
Yes, sir. Understand po.
Yeah, thank you.
Salamat.
Okay, so are we good with that, Engineer Bliven?
Yeah, I understand. Thank you.
Okay.
Um,
We have
Um,
here.
yeah.
Yes.
yes, sir.
Another question from PP John Lora.
Yes, sir, June.
Sir June.
Magandang gabi, umaga, o ano ba dyan, ka-Grace, ka-Ace. How are you?
Good po, Sir June. Magandang umaga, magandang gabi po sa inyo lahat.
Okay, marami akong question, but alam mo, kaya-kaya mo itong sagutin eh.
I hope.
First,
Yes, sir.
how do we determine the R value?
That's a good question, sir. So typically, some projects, if we don't have any information, but we have information, what is the time that projects have been built? So let's say wala tayong information about the building and we want to model or know what's the R value of the building. So let's say that building had been built in year 1999 or 2007. Because eventually, let's say here, it's very easy because all the buildings still have to comply on codes during that time, right? So if it's built in 2007, then I'll look at the ASHRAE code prior or during 2007. So ASHRAE had a recommendation about the thermal envelope value of that wall or glazing. Otherwise, if you have existing building or as-built drawing from the architects, let's say they have a detail of certain sections of the wall. Let's say the wall have this much thickness of insulation, this much thickness of concrete. you can actually calculate that using the resistance value. So like heat transfer information where we have during our universities or college, we can easily calculate that thermal resistance from the architectural detail. So doon natin malalaman kung ano yung total overall resistance value, and even what will be the thermal bridging effective R value kung nasa cold climate ka like here in Canada. But otherwise, if you're in a tropical climate, you don't have to concern yourself about thermal bridging.
Okay. My second question, Engineer Glenn,
Yes, sir.
Itong software na energy modeling,
Yes, sir.
what is your recommended? Marami kamo yung nagpo-provide ng ganyang software. What is your recommended software na madali nating maintindihan? Is something like this is new to us?
Yes, sir.
So if we want to apply it, nadaanan mo na yon. So I think if you can recommend to us, ito ang madaling estudyohan namin, and then maybe we can use it on the field. And secondly,
Yes,
kung mayroon bang software na energy modeling na pwedeng libre lang from the internet, or do we really have to buy it, and roughly how much would be the cost?
That's a very good question, Sir Jun. So for energy modeling, you can start doing like from reading books. There's a lot of energy modeling analysis, not only software. Like you can start from having spreadsheets. Let's say you have calculated meron kang lighting schedule, and let's say kahit sa bahay mo, so you count the number of lighting in your house.
Yeah.
And then let's say you improve your lighting. You want to improve your lighting by buying LED. So I've done it actually when I was in Singapore. And so we're using fluorescent lamps during that time. And then I calculated ano yung energy consumption niya per day. And then I just multiplied by 365 days. And then let's say you bought an LED light, right? And that LED light reduces your lighting energy by, let's say, 50% because LED maraming mas efficient na LED there. So how much can you reduce in energy? And you can actually, and that's already a basic energy modeling process na nagawa mo in your house and also in your building or in your plant if you want to implement that. So you can start there, and you can start even dig further. Let's say you can rebrowse kung ano yung dati nating nagawa during college, like heat transfer, HVAC. So in heat transfer, let's say meron kang envelope sa bahay mo and you want to add additional insulation. Let's say even sa ceiling, yung bubong natin walang insulation, then therefore you would have a lot of conduction load or convection load there. So what if yung bubong natin nilagyan natin ng ceiling, so there's improvement in the heating load as well. So what if yung ceiling natin or yung bubong natin nilagyan natin ng insulation? So you can see that even on the calculation ng heat transfer, you can see that it would reduce the heating load. So I would suggest to do Excel spreadsheet first, just to see, just to test at your home or at your plant the basic energy modeling principles. And once you have done that, then you can go further. Like this one is Equest. So this software, I'll combine the two questions. So this software is pretty basic. Well, it's not that basic compared to the Excel spreadsheet, pero mas madali siyang maintindihan. There's a lot of energy modeling software that are very complicated to understand. But here, this software is quite basic. You can easily learn this online. And the other good thing of this software is it's free. So you can just download it online, try to just browse it, learn from it. And it's also, this software has also been utilized by different countries like US and Canada. Even for LEED, this is still a recognized or accredited software for LEED certifications. And if you're doing permits here in Canada and US, this software is still accredited to do energy modeling. So it's free, and it's still a good way for you to start your energy modeling career or your project. And kung ano man yung ginagawa ko from a different software, because I use a different software called ISVE. So even it's a complicated software, pero the energy modeling process or methodology that I've done on ISV is almost the same thing here in eQuest. So it's a good start, sir.
Okay, thank you, Engineer Glenn. Mayroong last question na lang, if you don't mind.
Sure po.
In your presentation, sabi mo na you can have the maximum savings during the pre-planning stages of the design of the building.
Yes,
Tama
sir.
po. So, all right.
Yes, sir.
So, do it needs to be that the building design is already completed with the architect doing all the necessary structure or whatever at these appurtenances of the building, so that we as mechanical engineers can determine the energy modeling for that particular building or not?
That's a very good question, Sir Jun. Especially in the Philippines, even here in Middle East or in North America, sometimes we work in silos, right? So pagka ang architect gumawa ng certain building, they don't want to listen in other mechanical trades or electrical trades. Same with our mechanical engineers. So that's a big problem that's happening in the actual industry, where hindi tayo nakikinig sa bawat isa. And therefore, let's say that's exactly we have to do or convince the client or the architect that what they design affects us. So let's say and vice versa, right? So let's say the architect build a building that has a lot of glazing and very poor insulation R value or envelope, right? So it would increase our mechanical system. So from that, once we increase our mechanical system, it will increase our piping for chill water, our ducting, and our ventilation. So we would need a lot of ceiling void or ceiling space. We would need a lot of bigger mechanical space. We would need bigger shafts and openings because we have bigger pipes and insulation and ducting. So that affects the architectural design as well. So we would have to sell to them na, if you don't want to listen to us, then once we design our mechanical system, you'll have a lot of trouble because we'll need a bigger system, bigger mechanical plant. And same with the electrical, they would say, okay, we'll have this massive load from the mechanical, then we'll have bigger transformers, we'll have bigger panels, and that requires space as well. And same with the structural. Well, yung mechanical system yung mabigat and electrical system, then we will have to reinforce that and design a bigger steel, a bigger column, and therefore it will affect the mechanical, the architectural drawings or system. So it's all of us are interconnected. So you can say to the architect, if you don't want to listen, then you can see here, and once you realize you made a mistake after the schematic design, you would need a lot of effort just to solve the problem, and therefore you have minimal savings. So that's the way we have to convince each of us that we have to work each other during the pre-design and schematic design. Otherwise, it's too late. The equipment are already installed, or if the design are already built, and you have a limited amount of budget and time to finish the design.
Thank you very much, Engineer Glenn. Thank you very much. God bless.
Thank you, sir. Thank you, sir.
Thank you also, Engineer June, past president of 2001, WRSA.
Thank you.
Thank you, sir. And we also have question from our PP for all season. Sir Nap.
Yes, thank you. Thank you. Vice Alvin.
Sir Nap.
Yes, Ka-Ace, thanks for that very good presentation. At least kahit kami ni Ka-Jun Laura na senior na, may nadagdag pang knowledge.
For sure, sir. Marami akong natutunan din sa inyo.
Well, actually, my question is related to the question of Engineer June Laura concerning the how to calculate the R value. Because my question is it still feasible to do energy modeling for existing buildings? Yung nakatayo na yung building, ginagamit na, but then maybe we need to do some modification or ways to save energy. So is it possible to do energy modeling on existing buildings?
That's a very good question, Sir Nap. So because our buildings, so lahat naman tayo, once we design new buildings, eventually they will be existing buildings, right? And there's already a lot of existing buildings, not only here in Canada, but even in Saudi Arabia and also in Philippines. So there's a lot of retrofit projects. So let's say this is just one sample, Sir Nap. So let's say during the plant operation or building operation, you can see that there's a big spike during the summertime of energy, air conditioning, right? Or any systems. And then once you have a spike of energy, sometimes the actual building or energy provider would penalize you. So may penalty once na lumagpas ka doon sa energy,
yes.
right? So you're penalized based from that. And if you want to at least know how do you actually save, so you have different kind of energy conservation measures. So say, okay, we'll do this system. We will have to implement this kind of system just to reduce the energy and therefore not being penalized. You can do that doing Excel spreadsheet, but if you do it in the energy modeling software, you can actually have a credible result. Kasi based on the energy model that you have done, you have proved that this system actually works compared to the other system, and therefore shade the peak, and therefore not being penalized by the provider. That's already one sample that we have demonstrated again and again in actual existing building.
Yeah, okay. That's a good answer. It's well taking note. Then my next question is, what is the minimum building size if I am designing a building that energy modeling would be feasible? Yung cost ba paggawa ng energy modeling? Kasi baka naman ang liit lang ng building, mag-energy modeling ka pa, mahal pa yung cost ng paggawa mo ng energy modeling. So ano yung at least roughly, approximately ganitong square meters ng building, then you can do energy modeling on that.
And that's a good question, sir. To be honest, sa akin personally, because our energy modeling cost depends on the requirements. So if and requirements is, let's say it's a small building, to be honest, I've modeled like 200 square feet space.
20 square meters, yeah.
20 square meters. And our fee for that is not even like a couple of hundreds of dollars. And usually the requirement for the dito sa code, if you have 20,000 square feet or like 2,000 square meters, that's actually a good area enough to do energy modeling.
I see. Okay, good. Thank you.
Yeah.
Then my last question is that after you have done the energy modeling and on a particular project, and then you constructed the project, then later on, after a few years, there is a change in topography. What I mean by this is, like gumawa ka ng isang high-rise na gawa mo yung energy model, natapos mo na yung building according to your energy model design, but then after 5 years, may nagtayo ng high-rise din sa tabi mo. How would it affect your initial energy modeling study na ginawa? At how would you adjust it in case?
Yeah, it's a very good question, Sir Nap. And it happens for us energy modelers na once we develop our model during design and operation, and suddenly in actual operation or construction, it's very different. So let's say your building is located in an area without any adjacent building, right? With walang kapitbahay katabing
Wala pa
building.
muna. Oo.
And it depends on which country. Let's say if you're in Middle East, right? You have high-rise building and may katabi kang high-rise building, then it actually saves you some money because once the sun hits that adjacent building, you'll have some shade. Though, so once you have shade in your structure, then you can save some heating or cooling energy. But I'm not saying that in general it saves you energy. There's some cases like if you have heating energy, or here in Canada, once you have shading, you lose the heating, the amount of heat inside the building. Therefore, your boiler would have to compensate for that.
Right.
And same with all the actual operations. There's a lot of energy modeling projects that I've done where during the operation, so I assume, let's say the door in the hotel door in the atrium would have this kind of let's say vestibule, and in construction they have vestibule pero bukas naman ng bukas, parehong bukas yung pinto, and therefore you have infiltration rate, and then they will say, how come the energy is so high compared to before? Then of course energy modeling, like design, is always based on assumption, right? So I assume your operation would be typically like this, but you open the door all the time. Or before you said that you have lighting power density of or LED lighting, and therefore, but you install this kind of lighting, or you install this kind of building envelope. So therefore, there's a deviance or difference between energy modeling and the actual operation. And what we will have to do there is go for an site investigation and see what's the actual operation of the building, and therefore I will calibrate my energy model based from that actual operation.
One more question, may naalala ko. Is it applicable for industrial operation? Kasi ganito, may isang glass factory dito. The owner it's an old glass factory, maybe 20 more years old. At yung owner is willing to pay sa sino man na makakapag-propose sa kanya na makakasave siya ng energy. Is it possible with the system and energy modeling?
Yes, sir. That's a good question, sir. So let's say the owner have an existing system, right? Let's say he have a boiler or he have a furnace that's emitting this kind of heat or cooling system to cool down products na init. So we can have multiple different ways, even in industrial applications. So let's say we'll have like ice storage or efficient boilers or furnace. Then we will test that in the energy model based on the actual load scenario for each of the process. So we will look at the process that they have and convert that in the energy model and see, let's say, what's the effect of like ice storage or having this efficient furnace or boilers. So once you run that energy model, you can see, oh, based on that, you can save 30%, 20%. And that relates to the energy cost or return of investment. So to me,
okay, yeah.
Yes, sir.
Yeah, go ahead.
Yeah, so to me, sir, regardless of any kind of application, kahit industrial, energy modeling can be beneficial.
Okay, thank you. And follow up to that, can I use the eQuest Quick Easy Energy Simulation software? Yung libre muna.
Yes, sir.
Kumita na ako, saka ako bibili.
Yes, sir.
Because once I get all the information, if I can run it on this software, then maybe I can come up with a draft proposal. Then pwede kong ipakita sa may-ari, roughly ganito. Pero magbayad ka muna sa akin, gagawin ko na yung final.
Yes, sir,
I
you
use
can
the
learn from
eQuest?
that.
Okay,
Yes, sir.
I will try to download it. Thank you very
Yeah.
much, Engineer
Yeah.
Ace, and maraming salamat. Okay?
Welcome,
Pues
sir.
Aldrin, I'm done.
Okay, thank you very much, sir. I guess I'm looking through our time and we're already at the 8:36 time mark. And with our presenter, if he can still accommodate some questions, and I don't know if Zoom will also shut down our meeting because we already passed through the 8:30 mark.
Okay, just proceed until we are shut down. Anyway, at the moment, magpapasalamat na ako kay Engineer Ace. Baka bigla tayong i-shutdown na ng Zoom. And thank you again, Engineer Ace, for your cooperation. And let us just proceed with the question and answer hanggang sa ma-sign off na tayo. Okay, Tues Aldrin, go ahead.
Thank you, Sir Nap.
We'll
For those
just
of
ask
you
that. Yes.
na you want to ask questions after this presentation, you can always either look me at Facebook or LinkedIn, or this is my personal email. You can almost email me at ngr.acecleangarcia@yahoo.com.
Okay, so Sir Ace, can you still accommodate questions?
Sure, sure.
Yeah,
Okay,
just
sir.
proceed.
So we will proceed. I think we have to give chance for others. So we will get back to Engineer Miller after. So from Engineer Lori Gabiola.
Okay. Magandang gabi sa amin dito, no, Engineer Ace. I was so amazed with the data that you have shared to us about climate change. And with regards to that, I was afraid, no, considering for the next 30 years, the temperature will be hotter. And how do you assess these changes, the climate changes? There will be a solar energy introduction in all beam designs. That's my question.
That's a good question, Sir Lauren. I don't want to be an alarmist showing that, in next 30 years, this would happen, right? This presentation in my mind is just to make you aware what will happen in coming years so that we can mitigate or adapt in the future. So when it comes to that, so let's say you have a knowledge now that 30 years from now, things would change. So let's say even now, Sir Lauren, let's say because before we don't have much storm happening, like right now, the storm here in the Philippines is becoming larger and even stronger. So we'll have brownouts and we'll have this much disaster. So kung maiikot mo yung building or yung house mo to withstand that force and also have PV, that would be great because once we have blackout or brownout dahil bumagyo, then you would have energy. You would have energy for your fan or aircon or TV or at least lighting compared to others na walang PV, right? And I would definitely recommend to have PV not only on buildings but also in residential application.
Yes.
I just hope that in the future, sir, there would be some incentives once you've done that, because I know once you install PV, kahit sa residential, lalo sa commercial, there's a first cost implication or cost implications for that. But in some countries, may incentives na once you install your PV, then you will have some monetary incentives or like tax break. Yung ibang country, they would have the energy provider like give them some incentives for that. But unfortunately, in Philippines, we don't have that. It's based on each individual private owner or businesses na i-pursue yung PV project. But even if you have you don't have any incentives for that, but the benefits you can see that, let's say there's a brownout or any climate change issue, you're well prepared. Like you have PV, you have improve your envelope or your structure of your house. Now, once dumating 30 years from now, your children or your grandchildren would benefit from that. That ang ibang tao merong wala silang kuryente or wala silang they're not equipped, but you are equipped based on the knowledge that you know based from the presentation, kasi you know 30 years from now this would happen.
Yes.
Would likely would
Thank
happen.
you very much.
Yeah,
Yes,
thank you, sir.
I'm into this PB business sooner, no? So I think this is a good way to go into in relation with the beam designs. Thank you very much, Engineer.
Yes, sir.
Okay,
Thank you,
so
sir.
are we good at that, Engineer Loring?
Yes, thank you, sir.
Okay, yung PV mo, yung pulburon business.
Yes.
Okay, we will also entertain another question from Engineer Bong Hunsay.
Hello? Hello?
Okay, Engineer
Hello?
Hiller.
Nice to-
Yeah, I think. Can you hear me or?
Yeah, I can hear
Hello?
you.
Yeah,
Sir
please
Bong.
proceed.
Yeah.
Engineer.
Hi. Good evening. Sir, kasi I was in facility management. So, some of our buildings na handle namin is meron siyang BTU meters. So, I was tasked to do a tariff. So, how much are we going to charge the clients for every kilowatt consumption? But this kilowatt is not directly translates to electrical consumptions, right, sir? So, I need to take all components na included dun sa HVAC system namin para ma-charge ko sila properly. Including economics, yung initial cost and everything. Ang na-encounter kong problema, sir, during these things is wala sa limited yung mga meters, electric meters, I mean. So, hindi ko magawa ng kung magkano talaga yung consumption nung electric consumptions nung mga, for example, yung mga fans, yung mga air handling units, wala na sila eh. Ang mag-charge lang ng BTU meters is yung consumption through chilled waters lang. Sa heat exchange lang chilled waters. Pero yung consumption mismo ng fans, wala na ako. Pero kailangan ko pa rin silang ma-charge, ma-cover dun sa kung magkano i-rate ko. So, ang tanong ko, sir, dito sa inaano nyo na modeling, pagka may maglalagay sa building itself, maglalagay ako ng equipment, do I need all complete details ng mga equipment para magawa niya yung magkano talaga yung consumption niya or yung gamit niya ng electricity, or magkakaroon siya ng rough estimate or meron siyang sinusunod na parang sa HAP, meron siya, di ba, parang estimate kaming magagawang values doon para gawin niya yun?
That's a very good question, Sir Bong. So, mas mabutit meron kayong BTU meter at least sa chill water operation, right? So,
Yes.
what I usually do, this one is for energy auditing. I just use the BTU meter ng kliyente kasi eventually the BTU meter would record that energy based from the consumption ng fan cold unit or air handling unit. So, ang air handling unit naman, so once it requires additional load, you can see that it requires like additional chill water flow, right? So you can record that in BTU meter, in your BTU meter. And then afterwards, once I know each individual tenant BTU meter, I will normalize yung kung ano man yung fixed charge at yung demand charges ng energy provider to each of the BTU meter. That's what I would do. Some clients or some people, they charge based on the capacity ng fan cold unit, but the problem there is kahit ba malaki yung capacity ng equipment, it depends also on the consumption, right? So
Yes.
I would definitely recommend to just normalize your energy cost based on the BTU consumption.
So lahat, ano ko siya as per rate, ibase ko na siya sa BTU consumption.
Sa BTU consumption, yes.
Oo. Doon na ako magbabase sa kanya. Ang
Yes.
issue ko doon, sir, is for some equipments, for example, wala ako nun direct na details nun. So, dito sa BIM, pag gumawa ako ng model, hahanapin niya rin ba yun? Yung direct ng complete details nun para magawa niya ng electric consumption.
Yes, sir. Kailangan mo ng complete detail, like the actual nameplate ng fan cold unit or air handling unit. Kasi, let's say, even for HAP or EQuest or IES energy modeling, you will need to know kung ano yung capacity ng fan cold unit at ano yung actual either chill water or hot water consumption nun, so that it would give you some accurate annual energy results. Kasi let's say you assume based on load na okay, ang requirements ng room na to ay 10 tons. And then once you operate it, inassume mo lang yung flow requirements ng fan, or even inassume mo lang kung ano yung internal loads ng bawat room. So it will lead you to misleading result na you would bill this tenant based on that assumption na you just assume a certain percentage. So if you know what's the actual fan cold unit or cooling load for that space, and what's the actual internal loads for that space, then it gives you some idea, rough estimate on what's the probable operation for that tenant space.
If I am using, for example, I am using Revit, pwede ko ba sa Revit ko na ilagay yung details and directly makukuha na itong modeling sa BIM yung details na, or kailangan ko siya pa-i-input na pa isa-isa sa BIM?
Kaya kung may Revit ka, okay din, pero kahit AutoCAD lang, sabihin mo you have a floor plan for CAD, you would have to model that in your energy model, because there's some Revit doesn't have energy modeling capabilities, not unless you install a plugin, and plugin you would still have to buy the energy modeling software. So if you have EQuest, kasi ang EQuest, it's not compatible with Revit, so there's no plugin for it. You would have to convert that doing CAD and then CAD to EQuest.
Okay, understand. Thank you, sir.
Yeah.
Thank you, Press. Thank you. Yeah, clear.
Wala na tanong?
Wala na.
Wala na, ako magtatanong.
Kung wala na, you can still email me all your questions kung meron.
No, I have one quick one, Ace, if you don't mind.
Sure.
I just, since we are talking about modeling, I just wanted to know how accurate it is against actual performance. Say for instance, in your experience, gano'n siya ka-accurate against yung actual na nangyari? Say for instance, gumawa ka ng model ngayon, hindi natapos yung building. How accurate is it?
That's a good question, Sir Elmer. The accuracy of the energy model depends on a lot of factors based on the actual operation. First, the inputs. So if you assume a lot of things based on certain number, let's say you assume lighting power density, walang actual na ano, hindi mo siya tinignan based on the actual operation. You assume certain schedule of operation, you assume number of people. If you assume a lot of things, then it would mislead the energy modeling results. And same with the skills of the energy modeler. So let's say you have all the inputs na nakuha mo based on site or construction, but you don't know how to model that correctly. Let's say you can't model dome, or hindi mo alam paano i-curve yung facade, or you don't know how to input properly kung ano man yung information na required, then it will mislead your energy modeling consumption. And same with the actual operation. Like I said, if I assume na the doors will be partially open from time to time, and then on the actual operation, it's laging bukas, lahat ng bintana, lahat ng pinto bukas, then it have a lot of infiltration rate, and it will have energy loads much higher than the energy modeling. So to be honest, energy modeling does not actually reflect the actual operation, kasi there's a lot of factors involved na from to have a deviance from the actual energy load to the energy model. Ang energy modeling software kasi, it's a tool for you to drive the design. So let's say you have certain architectural mechanical systems that you want to test. You can test kung ano man yung relative performance of that system. So it's actually just a design tool for you para makapag-isip ka, makapag-design ka kung ano yung dapat na system that you want to put in place.
All right, okay. So it's just a tool. Sa tool lang niya para i-guide lang yung mga designers natin.
Yes.
Okay.
Yes.
All right.
Okay.
That's it. Thank you. Thank you very much.
Thank you, PP Elmer.
Thank you, Dan. Thank you for inviting me also. Thank you.
Okay. So we will entertain another question from Sir Jeff. Engineer Jeffrey, sir. Please raise your question.
Yan. Nag-mute ako eh. Okay, good afternoon. Can you hear me, Engineer Ace?
Good afternoon, Sir Jeff.
Oy.
Yes.
First of all, good afternoon, engineers. Ito yung mga, nakita ko yung mga talagang mandirigma ng PSME WRSA. Good afternoon sa inyo. Okay. My questions is related to questions of Engineer Laura, Engineer Nap. It's all about its HVAC. Now, as I understand, paikot-ikot yung energy modeling more on envelope. Okay? So, ang tanong ko kasi is maraming retrofitting works dito sa Saudi Arabia. So, para maging effective or similar to energy modeling ang magiging resulta ng design is, ang una kong gusto malaman is, meron ba kayo napag-aralan na o nag-come up kayo sa R value ng materials na dapat gamitin para at the same time yung heat transfer coefficient is ganyan, ma-stabilize nyo na para yung epekto nung sa air conditioning load is similar or malapit na dun sa ginamitan ng energy modeling.
I see. Thank you very much, Sir Engineer Jeff, sa question. That's a really, really good question when it comes to HVAC. So, all energy modeling software doesn't just model the effects of the building facade. It can also model like chillers, what's the boiler operation, what's the actual HVAC, like variable air volume or fan cold unit. You can actually model that in the energy model. When it comes to your question on, let's say, what's the R value, recommended R value that we have.
Range actually, range.
Yeah.
Para ano na.
To be honest, it would be hard. It depends on the project. I'll show you one presentation where I told that the building depends. The R value of the building depends on the system. So let's say we have done the energy model, right? So you can say that, okay, just use R value of 20 on the building, and then once we run the energy model, I'll put this one is from the Excel spreadsheet graph. This one is just to check what's the effects of the building envelope compared to the mechanical system. So we will have, let's say this, because this one is in Canada, you can see that half of the energy is in heating, and the rest, like 13%, is just cooling load. So, and in the Philippines or even in Saudi, you can see this might be different. Like probably half of the energy is cooling load, right? We have this calculation where we can see what's the effect of the building. Here, we use an R value of 20 and R value of 30. So, or from 15 to 20. And when we plot the energy modeling results, we can see that, hey, the wall conduction and roof conduction, or the actual building envelope itself, only contributes to the energy by a percent or 3% or 2%, or let's say maximum 5%. So you can see that, oh, we don't have to invest so much on the actual building envelope itself, because based on this energy modeling, we can see that the effects of building conduction and convection in the building is minimal. But we can see that the preheat and air here contributes to 52% of the heating energy. So instead of going through improving the building envelope, we would have to contribute to improving our mechanical system, like by having ERVs or different kind of controls, so that we can improve the energy in the system. So I would say we would still need to do energy modeling first, because kahit i-improve mo ang building facade, some buildings only equates to like 10% of the overall energy. So it's hindi siya ganun ka-importante. And some buildings I've seen have the building configuration, because there's a lot of solar exposure in their buildings, that the building 20% or 30% of the energy is from the facade. And that's the way where we can actually dig in and analyze ano ba ang dapat na energy na R value ng facade. Looking at that facade, it was just 15%, R15. And then when we added like R25, we saw that there's a huge drop of energy based from that facade. So in short, there's no like complete recommendation on the building R value, but I would say that use the ASHRAE ASHRAE 90.1 guide as a minimum R value insulation for all your projects on different climate zones. So that's, to me, yun ang pinaka-minimum R value that you can install. But once we run the energy model and we saw that the background of, there's a huge effect on the building envelope, then we can further investigate that and see if we can improve the building envelope. Kasi once we improve the building envelope, there's a financial cost implications as well.
Okay. All right. Thank you very much, Engineer Ace. Kasi
Thank you.
may follow-up question ako. Kasi yung ano pinanggagalingan kasi nito is pagka properly design yung building, nagkakaroon ng yung selection of the equipment is malapit na diyan sa sa energy modeling after applying energy modeling. Now, pagka ang building naman improperly designed, meaning yung designer is nagse-select siya ng bigger size of equipment. Bakit namimili na bigger size? Because along the way merong loose coordination or lousy coordination with the architects na hindi na isama sa system, or yung nagkakaroon since merong wrong coordination or improper coordination with the architects, nagkakaroon ng unnecessary infiltration and exfiltrations or wrong usage of airflow, then ang nagsasuffer talaga yung equipment, and then at the same time ang loser yung owner kasi siya nagbabayad ng lahat ng ito So in my case, kaya ako tinatanong yan, gusto ko kasing i-impose na meron na yung kagaya today, meron na akong opportunity to impose na dapat ang mga material is ganito lang ang mga thermal resistance dito sa range na to. Otherwise, pwede kong i-prove sa kanila using HAP na you are exceeding the energy for the building, then you are suffering in the billing. Yun, pwede ko nang i-prove na ng ganyan yan. Kaya sa inyo mga energy modelers, kaya gusto ko malaman na saang range pumapasok na dapat ganito lang papasok ang R value ng mga materials na gagamitin, and then at the same time gusto ko kasing malaman how to recommend doon sa mga existing building na dapat palitan to mga facades yung ganito, yung mga materials yung ganito, because you are suffering in the long run, and to anticipate the worst weather condition in the future 30 years from now or 10 years from now and onwards.
It's actually a good suggestion, sir. So once you have an existing building or a design from the architects, you can check their architectural detail. So let's say they have this much insulation value, they have this much concrete thickness, and once you calculate the actual resistance value of that envelope, let's say it went to R7 or R10, you can say to them that based on the ASHRAE, you're not complying. Your in value is so small, and the recommended R value ng ASHRAE as per this climate zone is, or let's say your local code there in Jeddah or Riyadh, they have certain recommendations on R value of the building. If they're not compliant with that, then you can tell to the architect and to the owner that the architect's selection of materials in their building facade is so small that it would compensate with our mechanical system would have to compensate with the additional load because of that, and therefore it will suffer our design. So you can tell that to the even without the doing energy modeling itself, you can tell based on the ASHRAE requirements.
All right.
But
Okay.
yeah, but it does help the design or inform the owner if you have the energy modeling in place, especially if you can see this graph where, let's say, because of the design of the architect, 30% of your cooling load is based from the building envelope. so much that the mechanical system would have to compensate for that load.
Okay. All right. I think that's it. Thank you very much, Engineer Ace. It's just triggers me today because parang nabuhay yung interest ko to go more on energy modeling before. Unlike pa before na alam naman yung Saudi DR is limited ang exposure ng Pinoy Dan at saka yung access. It's very interesting itong subject matter na to, itong webinar na to. Thank you very much. At marami ako i-apply dito na rules to improve the design sa aming sa HVAC namin. Since
Thank you, sir.
ako na yung in charge ngayon, hindi na yung kagaya dati na kahit anong effort mo, meron pa rin naka-umbrella sa'yo. So, yun. Thank you very much, Engineer Ace. Thank you very much, engineers, lalo na yung mga mandirigma ng WRSA. Thank you very much.
Okay, thank you, Engineer Jeff. We entertain last question from Engineer Miller.
Hi, sir. To sum up the webinar, and good evening, good morning, and good afternoon, sir. Itong BIM pala, na-realize ko lang, ito yung sa lead, di ba, na-mention mo. Ngayon, bago to eh. Wala talaga akong idea nito eh. And then now, since nakita ko na yung trend is that yung lead, yun lang yung naintindihan ko. Ngayon, na-mention mo about sa lead, ito pala yung anong tawag ito, ito yung parang software na ginagamit nyo para mag-comply doon sa lead, right?
Partly, sir, Engineer Miller. So, ang lead is, ang BIM also caters for lead, but not just particularly to lead. So, like individual projects like what I mentioned on the graph. So, here, regarding the purpose, like let's say, so this one for building energy modeling and even for BIM, hindi lang lahat ng BIM ay just for compliance. It has different purposes for us. So hindi lahat ng projects natin need to comply for BIM, but also need to comply with codes or permit or client expectations.
Okay, sir. Punta ko doon sa direct. Anong ika-advise mo sa amin? Kasi nakikita ko yung career path ngayon natin lahat. Actually, nakita ko na yung requirements. Actually, ang mga malalaking company pa lang nagsisimula eh. Nakita ko lang, na naging interest ako kasi sa company namin di pa rin na-implement. Requirements na rin part of the safety is knowledge on lead. At anong ika-advise mo sa amin? Kasi parang ito na yung trending ng ng career path towards ng parang magiging part na siya sa engineering requirements eh. Nakikita ko. Although isang beses pa lang ako nakikita sa sa site na nag-required sila ng knowledge on lead incorporating with the QEHS knowledge. Parang ini-incorporate na nila diyan eh sa QEHS.
Yes, sir.
So anong ika-advise mo sa amin, sir, as your fellow engineers na ikaw yung expert ngayon, so papunta tayo doon at maganda yung so wala akong idea, so kailangan ko ng advice mo kung anong steps at paano anong ikasabi mo sa amin.
Thank you, Engineer Miller. With regards to lead, sir, I would definitely recommend it to study, and lalo kung maging lead certified ka or accredited professional. Kasi it does not only show na meron kang good credibility and understanding of lead process, but also when it comes to energy conservation and also sustainability as you as a professional. So let's say if you're a mechanical engineer or you're a plant operator, you have the know-how of sustainability. Let's say if you're designing an HVAC system, you have to make sure that the occupants that will be operating that system So let's say you just design your building based on peak load. Okay, so you assume it's 100 tons on your building, pero sa loob naman ng building, it's so cold na ang tao nanginginig. Then you don't have a good enough thermal comfort inside your space. So LEED actually enforces you to do what's the proper design on that, and also not only having a good building occupants or good indoor environmental condition, but this also have a good financial implication. In Philippines and in Saudi, I would definitely recommend learning LEED processes because it's a way for you to think more on how you design your buildings or your system. Unlike here, some of the building codes here in Canada and US are already in place. So yung local codes namin here in Ontario, it's already, there's some LEED or like energy efficiency requirements already, so that sometimes the projects doesn't have to comply with LEED or doesn't have to show that they have energy efficiency because the code, the municipal and federal codes are already in place.
Okay, sir. Thank you, sir.
Yeah, welcome. Thank you, Engineer Mera.
Okay, so that was our last question. So, wala na yatang magtatanong na iba pa?
You can always email me here at my personal email if you have any questions, and I'll be glad to respond and answer the questions.
Okay, so with that, before we wrap up this technical presentation, I would like to personally thank our technical presenter today, Engineer Ace Glenn Garcia, and to all of our participants, lalong-lalo na sa ating ika nga na Engineer Jeff, mga mandirigma ng WRSA. Nice to see you all here. We will be releasing soon certificates, but we have to coordinate with Engineer Ace how can we proceed with the certificate.